As mentioned in the introductory videos, Jetpack Compose works by often transforming your data into user interface. So data and state is very important in a Compose application. For example, when a user enters some text in a text field, we need a mechanism to keep track of the characters that they enter, and then we might want to display that text somewhere in our UI or perform a real-time search based on it. Therefore, managing state in Compose is very critical and important. In this video, I'm going to show you how you basically manage the application state in a Jetpack Compose app. For that purpose, I'm going to create a new project in Android Studio. I press New Project in Android Studio and select Empty Compose Activity from the New Project page. I press Next. Because it's about state, I'm going to name my application Compose State. And then I don't change package name, save location, and minimum SDK, and press Finish. We wait for the project to be created in Android Studio. Fine, our project is created. Next, I'm gonna remove the default composables added by Android Studio. I also remove the content set by Android Studio inside set content because I'm gonna set my own content. I create a composable by typing comp and then pressing enter. I'm gonna name my composable, for example, boxes screen or box screen. I will use mostly boxes to show the state that we will manage in this video. In order to have a preview of this composable, I'm also going to create a preview composable by typing prev and then pressing enter. I name it preview box screen. And then inside the box screen, I'm going to, let's not forget to call box screen inside preview, because we want to have the preview of box screen in our preview pane. And inside the box screen, I'm going to define a column. And then inside the column, I'm gonna have a big box. And for the box, I'm gonna set a size modifier.size, a size of, for example, 400 dep. Let's keep the size in a variable, val box size. Let's start it with a small letter, and 400 dep should do it. I'm gonna use 400 dep or dp for the box size and use it here as the size. Let's also give it a background. Import background. A background of red should do it. You can use any color that you like. And then after the box, I'm gonna have a text field. I use Material Designs outlined text field. Text field. For the value, I give a default value of 0 in a text as a text. And then after the text field, I'm gonna have 2 buttons in a row. So I will need a row, and inside the row, I'm gonna have 2 buttons. 2 buttons. Button. And inside the button, I'm gonna show their text. The first button is gonna show increase, and the second one is gonna show decrease. text. And why is that? Because we want to be able to increase the number displayed in the text field by pressing this increase button and decrease it by clicking this decrease button. Let's refresh the UI on the right by building the project. As the UI is being refreshed, I'm gonna add some padding for the buttons. 8 depth should be good. And for the second button, I enter pad and then Android Studio helps me complete it. Modifier that padding, 8 depth. Alright, looks like our preview is going to appear. I do a refresh. I also minimize the section on the left, the Project Explorer, to have more space for our coding area. And once the preview shows up here, I'm gonna press zoom to fit screen. Alright, it doesn't seem right. Okay, the column doesn't wrap around the other composables. I'm gonna remove its ending curly brace and put it after row. A refresh and it should be good to go. Another refresh. There we go. It's not that ugly. In fact, now I'm gonna center the items that we have inside our column. So I'm gonna do it using a modifier. I'm gonna do it using some parameters that are specific to alignment. And they include horizontal alignment, and that's the main parameter that I'm looking for. Horizontal alignment. And for its value, I need to specify a value that is of the type alignment.horizontal. So center alignment dot center horizontally. All right. Also, I'm going to give a maximum size for my column to fill the whole screen available to it. So I use a modifier for it. A modifier fill max size. It will fill the whole screen size available to it. And then a refresh. Once the refresh is done, we have our UI. Basically, this is the UI that we want. And then after that, we want to be able to increase the number displayed here by pressing the increase button and decrease it by pressing the decrease button. Also, for every count that we have here, for every number that we have here, we want to have a corresponding box, a child box inside the parent red box. So for example, if we have 2 here, we want to have 2 child boxes inside the parent. How do we do that? First of all, let's try this in interactive mode. Start interactive mode by pressing the interactive mode button in the preview pane. Increase, decrease. You see that it doesn't do anything because we don't manage state yet. And now I'm going to create a variable, a state variable that will keep track of the count of the number that we have here. So inside the box screen, I create a variable var, I name it count, and then its value is mutable state of. This will basically give us a state type value I import mutable state of, and I give it an initial value of 0 because it will start from 0. You might ask yourself, why are we using a state? By hovering, you see that it returns a mutable state. Why are we using a state and not a normal value, like for example an integer here? The answer is that you cannot use a normal variable because Composable will not understand any changes to that variable. But once you are using a state and your Composable uses a state, whenever the value of that state changes, your Composable knows that it should draw itself again or recompose. That's the reason why we are using a state and not normal type of variables. Okay, now we are supposed to use the value of count in our text field. So for our text field, I'm gonna use the value of count this way, string template, count.value, and in the buttons, in the increase button, each time this button is clicked, this count is supposed to increment by 1. So in the onClick lambda, I'm gonna type count.value ++. And what about the decrease button? Each time the decrease button is clicked, we are supposed to decrease or decrement the value stored in count. But what if the value is already 0? We cannot decrement it. We need to have a restriction for this value to not go below 0. So I type count.value equals, I use an if statement here. If count is less than or equal to 0, count.value, in fact, we need its value, not itself. Then return 0. If it is already 0 or occasionally below 0, we just set it to 0 again. We don't want to decrement it anymore. Other than that, otherwise, we decrement it. It is allowed to decrement itself. So count.value minus minus. Sorry, not minus minus, because we want to set the value to the left side to assign it to the left side. So I type count.value minus 1. Decrement by 1 and assign it to the left side. And this is a handy Kotlin if statement that can return a value. Okay, now we expect this code to work once we refresh our preview. So I refresh it and wait for the preview in interactive mode to be available, and then we are going to test our functionality. Okay, the interactive mode is active. I press increase. You see that it doesn't work. The value doesn't change. And the decrease button, it doesn't do anything too. So let's see what the problem is. Look, I told you that whenever you change a state variable, Compose knows that the composable using that state variable should recompose or called again or to be redrawn on a screen. And each time a recomposition is happening, the variables that are defined inside that composable are reset to their initial values. So for example, the count here is initialized to 0 again each time box screen is called, and each time this composable is recomposed. Therefore, we will never have a value other than 0 here, because each time a recomposition is necessary, the value is reset to 0. How can we fix that? Compose has a very nice mechanism for that called composable memory. And the way we use a composable memory and the way we give memory to a composable is by calling this nice function, remember, before defining your state. Remember allows the defined value, the defined variable, to be initialized only once. And then after that, each time a recomposition is done, it is not initialized from scratch. It remembers its previous value, the value that was initialized the first time that composable was called. So once we use remember, we should be able to solve that problem. I refresh my UI. Okay, now let's test our functionality increase. We need another refresh. Testing again. Okay, sometimes the preview just doesn't work or takes some build to perform correctly. What I'm gonna do is just stop using the preview for now, switch to code, and then run my code on the embedded emulator. That will also give the IDE better performance in comparison with the preview. So I'm gonna run the application in the embedded emulator after using box screen inside set content. So I call box screen here as the content of my activity, and then run the application by pressing run app or shift F10. Alright, our application is running inside the emulator, and now I'm gonna test the functionality of the increase button. There we go. You can see that the value is increasing and the updated value or state is displayed inside the text field. Also, in order to make this application more interesting, I'm gonna create some child boxes whose number is equal to the value displayed here, or the value of our state. So inside the body of the box, the parent box, I'm gonna have a for loop that will iterate over the number of our count and then create children in 0 until count dot value. A beautiful Kotlin for loop that will go from 0 until count dot value, not including the value itself. For example, if we have 2, it will go from 0 to 1. So I create a child box here and give it a size. I'm gonna make the child smaller than the parent each time. Therefore, I create a size here, var child size, I name it, and I started to box size minus 20 dep. And then modifier.size for the child. I'm gonna use child size here. And after that, in order to make it even more interesting, I'm gonna rotate it a little bit by some degrees, like for example, I multiplied by 3f, a 3 factor of the index of the for loop. And then I'm gonna give it a background of gray, for example. And also, to make it appear more prominently, I'm gonna give it some border. Import border, and the border's first parameter is its width or its thickness, 1.dip, and the color as a second parameter, color.black. I give it black. You can choose any color you like. Alright, let's send them to new lines so that you can see all the parts. So basically you see that each time we increase the number that we have, the count that we have, we should have another child box appearing inside the previous boxes. So let's run the application again and see the result. Testing functionality, increase. There we go. We have a child box appearing inside the parent box. Another box, another box, another box. But as you can see, the boxes are positioned on the top left of the parent box. I'm gonna fix that by centering the child boxes. I do that by adding an alignment parameter for the parent box. It is called content alignment. And for its value, I type alignment.center. I run the application again. Testing functionality, increase. There we go. We have a child box appearing. We have count 1 and box 1. Count 2, box 2. 3, 4, 5, 6, 7, 8, 9, 10, 11. Also, I'm gonna decrease the size of the child box each time because I think it will be more interesting. So for the size that I'm using here, child size, I'm gonna decrease it after drawing a child box. Child size equals child size minus 20 depth. I can simplify this by using minus equal. I do it automatically using Android Studio, replace with minus equal. And I run the application again. Alright. The boxes are being created, the child boxes inside the parent box. You can see. Once you press the increase button, a new box will appear inside the other boxes, the previous boxes, and when you press the decrease button, the last box drawn inside the boxes will be removed. This gives the impression that our application is intelligently adding or removing the latest box inside the previous boxes. But the fact is that each time we are running a loop and we draw boxes by the number of count that we have. So for 7, we draw 7 boxes inside the parent box. For 6, we are drawing 6 boxes. And this happens so fast and the user doesn't realize that we are doing this trick. So in this video, I showed you how to define a state variable and how to change its variable after remembering it. This is very important part. You must remember a state variable once you define it. And after that, you can follow the events that happen, like a button clicked by a user, and decide what to do with the value of your state, whether to increase it, to decrease it, and so on and so forth. I hope this gives you a basic idea of how Compose State works. But this is not all about Compose State. Please stay tuned for more about Jetpack Compose State.